In this video you will see some of the most interesting details of the monitoring for PV inverters from the manufacturer Solis, either from the Solis Cloud application for mobile devices or also from the Solis Cloud web platform through, for example, a personal computer. You are looking at the mobile app, the main screen, whereas installers we have access to the different installations that we have done. Here, for example, you can see two installations. We could access them, and well, if you want to give access to an end customer as an owner or as a visitor, you have to, for example, give access to the installation. Or as a visitor, you have to, well, modify the plant. If you haven't already done it, when you create the plant, you can modify the plant. And we can create an owner user. We would simply have to introduce the email. The customer will receive an email with a password. And she will have access to the plant as owner. We can also create guests so that they can visualize all the data of these plants that we have created. If we want, for example, to monitor from a personal computer, we can do it, as I said, from the Solis Cloud platform, from this web page. We simply have to enter our email address, our Solis Cloud password. And we can access to see all the plants that we have created. As installers, we can see a list of all the plants that we have installed. We have a first summary of the plants, what would be the plants that we have associated with our account, and also a summary of the different equipments that we will see next. In this first screen, we have a series of production statistics in real time, the power, the energy that we have generated today, 4.1 kilowatt hours, and some statistics and some more data that we can see. Here we have the two plants that we have created associated to our installer account. We can see that there is one of them that is online in green color, and then we have one in gray color that is in green color. Then we have one in gray color that is offline, possibly because it does not have access right now to the internet. We can see that we do not have any alarm, no error in the installation, and we can see, an alarm in the installation. And we can see, a map of what would be the plants, where they are located. And, some other data, such as, for example, today's production. So from this first tab, we can see the summary of the plants that we have associated. We can even enter in each one of the plants and see in real time, the statistics and the production of the inverter, as well as the consumptions and so on. You can see how right now we have just over 2.5 kilowatts of power generated, as we have a little less than half a kilowatt of consumption in the house. We are injecting the surplus into the grid, a little more than 2 kilowatts that we are injecting into the grid. Here you can see the energy balance today, in which, we have a total production of 5.7 kilowatt hours so far today, of which, we have self-consumed 30%, and we have injected 4 kilowatt hours into the grid. This would be the energy that we have left over from production and that we are injecting into the electric grid. As far as consumption is concerned, today we have consumed 2.7 kilowatt hours, of which, we have self-consumed 1.7 from production. But the rest, 1 kilowatt hour, we have taken from the electric grid. This would be the energy that we're going to buy from the electric company, 1 kilowatt hour. It surely corresponds to the consumption during the night. During the night we always have some consumption, and as we do not have solar energy, we take it from the electric grid. Here in this graph you can see, quite clearly what would be the photovoltaic production. You can see how today there are clouds. The production starts very well, but then here it drops because there are clouds. And you can see how at noon we are already reaching a production of about 2.5 kilowatts of production. We can see that, in this orange line we see the self-consumption, all the energy that we have self-consumed from the photovoltaic production. And we could even see the energy that we have injected into the electric grid. It would be the difference of energy that we are injecting because we have that energy left over. As for the consumption, here at the bottom you can see, the consumption that we have had today. You can see that during the night, there is always a small consumption of 4,100 watts, which is a small consumption of 4,100 watts, which corresponds to the refrigerator, etc. And then, from 9:45 o'clock onwards, we have a little more consumption, about 500 watts, more or less constant. but well, we cover it with solar energy, so well, we do not mind. Here we could see, well, that what would be the self-consumption. You can see how everything in orange would be the self-consumption, and in red, red, orange, you can check the energy that we have bought from the electric grid. Here you can see how when it starts at 8 o'clock in the photovoltaic inverter starts to produce at 8 o'clock in the morning, when we already have solar production. And from 8 o'clock in the morning onwards, we no longer have any consumption because we have photovoltaic production. During the night, logically, we have consumptions. We are buying energy from the grid. But as you can see, from 8 o'clock in the morning onwards, we no longer take energy from the grid. We no longer take energy from the grid. This would be in terms of the summary of the plants that we have associated to our account. As for the devices that we have associated to our account, we would have to click on this tab, and we see all the devices that we have associated to our account, in this case of installer. We can see how we have 2 inverters associated. Correspond to these 2 inverters, 1 in each plant, and we have associated 2 communication devices, in this case Wi-Fi devices. Here you can see how we do not have any other device associated. We can see the devices in terms of associated inverters. We can see the collectors or communication devices. In this case, we have associated 2 Wi-Fi devices. 2 Wi-Fi devices, they could also be Ethernet or GPRS communication devices. You can see how the signal strength of one of them is good, and then another one of them is disconnected. And well, here we could see, as I say, the devices that we have associated. We could click, for example, in this inverter, and we have access to all the information that the inverter can provide us at this moment. You can see how, as in the previous screen, it gives us the information of the photovoltaic production, consumption, and also the energy we are injecting into the grid. We can see that the last update of this data has been 2 minutes ago. It is updated every 5 minutes. And some more information in real time, as we can also see the basic information of the serial number of the inverter, the nominal power, and so on. And this part, which is very interesting, in which we can, well, see both the DC input, the panel input, as well as the AC output. You can see how right now we have 2 strings connected. It's a 5 kilowatt inverter, which has 2 inputs for 2 MPPTs. At input number 1, we have 5 panels connected in series. That's 171.2 volts. 6.6 amps, which makes a power of 1,130 watts. And then we have in string number 2. In string number 2, in string number 6, we have 6 solar panels, so we have 1,130 watts. 6 solar panels, so we have a little bit more voltage, 208.4 volts, 5.9 amps, which gives us a power of 1,200 and 230 watts. A little bit more power because, as I said, we have 1 more panel on input number 2. At the inverter output, here you can see the AC output information. We have the grid voltage, 235.9 volts, 9.6 amps. 9.6 amps and the grid frequency, so well, the inverter right now is giving us just over 2 kilowatts of power output. So as you can see, it's very interesting to be able to check both the input of the panels and the output of the AC power to detect if we have any problems or any drawbacks in the installation. In this lower part, we can see more precise statistics and graphs about, for example, some parameters that the inverter can give us, such as voltages or current of each MPPT input, the AC output, and so on. We can perform, for example, a direct current analysis of the inputs in which, well, we can see the voltages in green, the voltages in green, and so on. The voltages in green color, we could see the voltage of each string. Since we have 2 inputs, we have 2 voltage graphs, each one corresponding to a PV string. We could see the current in orange color and also, well, the power in orange color that the inverter is giving us in direct current. In this case, well, we could compare some graphs to determine and to know, for example, at what time the inverter starts producing the DC power, at what time the inverter starts producing in the morning, with what starting voltage, and so on. We could, for example, look at the voltage of string number 1. which, well, you can see how from 6:30 in the morning it starts to have voltage. You can see how here it is changing because there are clouds. It is a day in which there are clouds, and therefore also the voltage is affected. And you can see how, well, at 7:10 in the morning we have 168 volts. We could also superimpose, well, the production to compare and to be able to see when the inverter starts producing. When the inverter starts to produce, in this case, for example, you can see how, well, although we have voltage, the production really starts at 8 o'clock in the morning when the inverter starts to produce energy. This is because, well, we are using a 5 kilowatt inverter for, well, a series of just 5 panels in series, and, well, it's not the most efficient way to produce power. And, well, it is not the most optimal. The most optimal thing would be, well, to have more panels in series so that the voltage would be higher, and the MPPT of this 5 kilowatt inverter would, well, have an earlier initial startup and start the MPPT of this 5 kilowatt inverter. Would have an earlier initial startup and start producing power sooner. Surely if we connected this series of panels of 5 panels in series in an inverter instead of 5 kilowatts in a 2 kilowatt inverter, the production would start much earlier because the MPPT startup of the 2 kilowatt inverter starts much earlier. So, well, from this section we could see, well, the information of both the voltages per MPPT input, the current per input, we could see that as well. The power, as I was saying, the direct current power, and then, well, we could also see the alternating current voltages, well, a series of statistics that are very interesting, as well as the statistics that are very interesting, well, as I said, to check any problem that the installation may have and to determine if it is the installation and determine if it is due to, well, some specific string or some wiring and so on. Here you can see, for example, the voltage of the grid, which is quite stable. This would also help us a little bit to understand sometimes that there are inverters that are constantly restarting. Because if we exceed the supported voltage ranges of the inverter, well, it will restart. This is because there are times when some installations have a grid voltage that can exceed that range of the inverter, and, well, you can see how we could observe it from here, and from here we could observe it and we could determine if it is the problem, and in that case we could modify the parameters of the ranges so that the inverter does not restart. Here we could also see, well, a graph of the consumptions that would also help us to understand a little bit the consumption habits. For example, here you are seeing, well, what happens during the night. These peaks probably correspond to the refrigerator starts. The refrigerator is working intermittently. It stops, starts up, the inverter restarts. Intermittently it stops, it starts, then, well, there we have some startup peaks during the whole night, and then, well, when the refrigerator starts up, we have some startup peaks during the whole night, and then, well, when the refrigerator starts up, and then, well, when we wake up, breakfast, and, well, the different consumptions that we have in a regular home. And, well, this would help us to understand also, well, what would be the consumptions and habits. So as you can see, it would be very interesting to have all this information remotely available. Remotely, especially for installers, so that they do not have to travel to be able to perform checks. On the other hand, we have other sections. We have seen up to now the summary section, in which we have seen a summary of both the plants and the different devices that we have associated in our account. And then we would go on, for example, then we would pass, for example, to this other section in which we can see a report of the alarms and the status of the different devices. We could see a report of the alarms, and we could see the rate of incidences, as well as, for example, export to Excel. A report with all these types of incidents. Then we would move on to these other reports in which we can also export monthly, daily, annual, etc. reports also to Excel, from which we can share them with other programs. And then we would go to this other section, which is also very interesting, in which we can manage the different plants. We can delete, modify, and so on. We can manage the different equipment. We can also disconnect them, and so on. And even, well, we could organize and manage the users depending on the role they're going to play in the installation. We could, from this part, manage the users. Also, finally, we could verify the warranty of the different devices that we have associated, and so on. Associated to, well, check the warranty period. So, well, as you have been able to see, very complete monitoring for these inverters from the manufacturer Solis, specifically through this platform, Solis Cloud, and also through the application for mobile devices. In this case, especially for installers, very convenient to have on the same screen. This makes it possible to see at a glance whether all the inverters are online, whether any are offline or in alarm. This simplifies, therefore, not having to go to an installation and remotely perform a control and an analysis before going to the installation to check if the voltages are correct. And an analysis before going to the installation, well, check if the voltages are correct, if we have input in the 2 MPPT and so on. So as I say, very interesting and very complete, this Solis Cloud monitoring for Solis PV inverters.